All right, let's go ahead and look at the checkpoint number 7. So this first question here, I'm giving you a function. It's defined over, let me open this up in Edge again. So this function is defined on the interval -4 to 2. So that's a closed interval, which means that we have to have an absolute minimum and an absolute maximum. So that's one of the things we're going to be asked to look for. But first, we're asked to find any local extrema. So the way we find local extrema in general is through the derivative. So first thing I want to do here is to find the derivative of this function. So f prime of x is equal to, we can use the power rule on all these terms, 6x squared plus 6x minus 12. Okay, so here's our derivative. So we're going to use this for a lot of things, but to find where local extrema might happen, we would like to set this equal to 0. So if I set this quadratic equation equal to 0, the first thing I notice is that every single term in this quadratic is divisible by 6. So I'm going to divide through by 6, and I end up getting x squared plus x minus 2 equals 0. That factors into x plus 2, x minus 1 equals 0. So from here, I can write down, where's my draw? So I'll wait for that to wake up. If it's going to. Okay. So from here, I can write down my two critical values of f. Those are -2 and +1. So I might have local extremes at these points. So now we have to figure out if we really do, and if we do, what kind of extremes they are. Are they minima or maxima? So what I'm going to do here is I'm going to make a chart basically for all my possible values of x. So like I said before in the definition here, this function is defined from -4. So I'm not actually looking at, an infinite number of values. I'm looking from x equals -4 to x equals 2. And I want to pay special attention to those places where the derivative is equal to 0. So one of those is x equals -2. Another one is x equals 1. And I know that at those places, the derivative is equal to 0. So what I'm going to do here is I'm going to indicate that with this little horizontal arrow. That says to me that basically at those 2 points, I have a horizontal tangent line. Now, what I want to do is to figure out what the derivative looks like everywhere else. So I'm going to test a few values here. First, I will test what happens between -2 and 1, and I'm going to choose the value of 0. So what is f prime of 0? That's equal to 6 times 0 squared plus 6 times 0 minus 12. So that's -12. I care less about the -12 and more about the fact that that's a negative number. So a negative number tells me my function's decreasing. So that's valuable information. Now what can I do? I'm going to test the function at -4. Actually, let's do -3. So f prime of -3 is equal to 6 times -3 squared plus 6 times -3 minus 12. So that gives me 6 times 9 is 54 plus 18. Nope, not plus 18. Minus 18 minus 12. So that's going to come out to be, looks like 24. What I really care about, though, is that it's positive. So I have an increase up to this point, and I have a horizontal tangent line, and then I have a decrease. So that tells me that's enough for me to prove definitively that I have a local maximum or a relative maximum, whichever term you prefer, at x equals -2. Now, it looks like we're going to have a relative minimum at x equals 1, but there's one thing we have to make sure of. The one thing we have to worry about is, well, maybe this decreases has a horizontal tangent and then decreases again. So we want to make sure that's not happening. So I will now check what happens at 2 with the derivative. So f prime of 2 is equal to 6 times 2 squared plus 6 times 2 minus 12. So that's 24 plus 12 minus 12. That'll be 24, which is a positive number. So I actually do now know that I have a local. So one more thing before we go. So I specified here, I want X and Y coordinates for my answers. So let's find f of -2. F of -2 is equal to 2 times -2 to the third plus 3 times -2 squared minus 12 times -2 plus 4. So 2 times -8, that's -16, plus 3 times 4, that's 12, plus 24, plus 4. So what does that come out to be? 12 plus 4 is 16, plus 24 is 40, minus 16 is 24. Okay. So what does that tell me? I have a relative max at -2, 24. So that's one piece of information I want. Now I want to find where I have a relative minimum. So to get the y value there, I need to plug in 1 for x. So 2 times 1 cubed plus 3 times 1 squared minus 12 times 1 plus 4. And that equals 2 plus 3 minus 12 plus 4. That's -3. So what does that say? That means I have a relative minimum at 1, -3. And because the derivative was equal to 0 at those 2 points and those 2 points only, I am done looking for relative extrema. So that's all for part A. Part B asks for absolute extrema. So where do absolute minimums and maximum points take place? Well, they could take place at relative extreme points, or they could take place at the ends of this interval. So that's the endpoints are where we have not looked yet. So now let's look at those. So this function is defined from -4 to 2. So let's do that now. What is f of -4? F of -4 is equal to 6 times -4 squared. Nope, I am using the wrong function entirely. Let's try again. 2 times -4 cubed plus 3 times -4 squared minus 12 times -4 plus 4. Need a little more space. So 2 times -64, so -128, plus 3 times 16 plus 48 plus 48 plus 4. So 96 plus, so that's 100. So -28 plus 100 is -28. So let's keep this point off to the side, -4, 28. So we have to look at one more point, but so far, this tells me that my relative max cannot be my absolute max because I found a greater y value. So my greatest y value that I've seen so far is 28. So now we have to look at the other end. F of 2 is equal to 2 times 2 cubed plus 3 times 2 squared minus 12 times 2 plus 4. So that's equal to 16 plus 4 times 3, 12 minus 24 plus 4. So all told was that 28 plus 32 minus 24 is 8. So the other point I have is 2, 8. Okay, so now we're looking for absolute maximum. So let's look for the absolute maximum first. The y values I've found at all my candidate points here are 24, -3, 28, and 8. So that means my absolute maximum occurs here. Now to find the absolute minimum, I have to look at all my minimum points. I have 24, -3, 28, and 8. So my relative minimum, this is also my absolute minimum. So this takes place, on the middle of the interval somewhere. Whereas the absolute maximum takes place at the left end of the interval. All right. And that is all for number 1. Let's move on to number 2 here. So I have this window that I'm making out of 2 pieces of glass, one rectangular, one half circle. So basically we want to optimize this. We're not told yet whether that optimum is going to be a maximum or a minimum, but we're finding some critical value for something. So find a function for the area of the window in terms of the radius r. So that is typically not something we can do first, but let's write down the area as a function of what? I'm going to leave that a blank. An area as a function of something. So I have an area of a rectangle. How do I find an area of a rectangle? Base times height. So that'll be 2r times h. So 2rh plus the area of a half circle. So what's the area of a circle? The area of a circle is pi r squared. We only have half of that. So this is going to be plus 1/2 pi r squared. So for now, we have an area function that's a function of 2 variables, radius and height. But we were told to find the area as a function of radius only. So we have to have another function. So this is basically going to be, I believe, what the videos describe this as, the objective function. We're also going to have a constraint function, basically some rule we have to follow. So, and the reason that's important is, if there were no constraint, this is a very simple problem. What's the maximum area? Okay, just make the biggest window you want. Because you haven't constrained me. You haven't given me a rule, like you haven't given me some kind of requirement that I have to follow. And on the other side, all right, what's the smallest window I can make? Okay, I'll just use as little glass as I want. No glass at all. But we are told that the perimeter of this window is 8 meters. So let's look at that. How do I find the perimeter? Like, what does perimeter mean? Perimeter is basically the distance around the outside of some geometrical shape. So let's just start from this point here and go in this counterclockwise direction. I mean, you can, however you choose to organize it is fine, as long as you get everything. So the length of this side is going to be 2r. And then going upward, that's h. Then around the outside of the circle. So how do I find the perimeter around a circle? It's 2 pi r, but I only have half a circle. So that'll be pi r. And then finally, I have one more length of h. And I know that when I add all those things together, I get 8. So I believe one pair of like terms in here combines. So I get 2h. I'm going to go ahead and factor out a r as well. Plus 2 plus pi times r equals 8. So what we were asked to do is to find a function for this area that is only expressed in radius. So what I'm going to do here is solve this constraint equation for h. So I get 2h, how about a real h? 2h equals 8 minus 2 plus pi times r. That leads me to this. H equals 8 minus 2 plus pi times r all over 2. So now I think I can plug that h back into, my area as a function of 2 variables to get this area, and this will be written in one variable only. A of r is equal to 2 times r times this quantity, 8 minus 2 plus pi times r over 2 plus, oh, hold on, did I do anything else? Yep, 1/2 pi r squared. I'll go ahead and clean this up one more time. These 2's cancel. And I get that this area is equal to, let's go ahead and divide, multiply that r as r through as well. 8r minus 2 plus pi times r squared plus 1/2 pi r squared. All right, so we could simplify this a little more. I'm going to leave it like this. If you chose to simplify it a little differently or go a little deeper, that's totally fine. But this is also acceptable. But I'm sure that when I start grading this, you'll have many equivalent things as well. How come sometimes you erase and sometimes you don't? Whatever. All right. So that's part A. Now I want to find the critical value of R. So to find critical values or critical points, we need derivatives. So now I'm going to take a derivative of this expression. So derivative of 8r is 8. This derivative here is going to be minus 2 times 2 plus pi times r. And then this derivative is going to be plus pi r. And I want to set that derivative equal to 0. All right, so now what happens? Maybe now is a good time to start expanding these brackets. So what do I get from this? 8 minus 4 r minus 2 pi r plus pi r equals 0. So let's do this. Let's get everything with the r on one side and everything with, actually, there's one more thing I can do here. 8 minus 4r minus pi r equals 0. So now let's isolate the r terms. So 8 equals 4r plus pi r. Now let's factor out the r. 8 equals r times this quantity, 4 plus pi. And one more step. R equals 8 over 4 plus pi. So if you want, you can find what the area is that comes from this point. I didn't ask for that. I'm just asking for what the critical value of r is. And we found that critical value. So we know now that when r is equal to 8 over 4 plus pi, we're going to get either a minimum or a maximum. That's what I've told you. Now we got to find out what kind of thing that is. So we could do something like this chart, and that's totally fine. But since I've already done that once, I want to show you another way to find that. We have a critical point. We can also do the second derivative test. So to do that, I'm going to take the second derivative of a, or the first derivative of a prime. So what do I get when I do that? The derivative of 8 is going to be 0. What's the derivative of these other two terms? So these other two terms are just linear. So what I'm going to be left with is -2 times 2 plus pi plus pi. So I actually have no variables here. So let's expand and simplify a little bit. So -4 minus 2 pi plus pi, that comes out to be -4 minus pi. So why does that matter? So the thing that really matters here is that -4 minus pi is a negative number. So if you have a first derivative, which is 0, that means you have a horizontal tangent. But we have a second derivative, which is negative, which means that in that neighborhood around where there's a horizontal tangent, the slopes of the tangent lines have to be decreasing. And if they're decreasing, that means they have to go from positive to 0 to negative. Which means I have a local maximum at this point. And that comes directly from the second derivative test. So that's all for checkpoint number 7.